All right. Hello, everyone. Welcome to the continued saga of trying to resurrect the computer that is missing from the cabinet over there, the Data General microNOVA. We left off yesterday waiting for this capacitor to finish reforming. I didn't let it completely finish because as it went on, I determined that it was, in fact, over-reforming beyond the point that it needs to have its dielectric built up to. So I ended up stopping that so that I didn't waste dielectric, or waste electrolytic fluid, building up the dielectric to a point that it isn't needed. Now, we also left off on this thing with the AC cap here. Now, this is a Heathkit, apparently C3 capacitor checker. Now, there is something I should clarify. In addition to the term condenser, meaning capacitors, I believe resonator also was, which was the other confusing part about the res. I believe I correctly identified it as resistor yesterday, but that was another term that could have been used for that, if I remember correctly. Now, I did look at a video that Helen Croft sent me on how to operate this thing, and my determination is that it's not going to help us with that cap, so we're going to put it away. It doesn't really seem like it's applicable to that exact capacitor, so, oh well. So yes. Lady Ironborn, thank you for the tier 1 sub there, and for 37. That's a complicated one. You know what? I'm just 37. Thank you, Lady Ironborn. Okay. So, let's see. God, what plans crave? Yeah. Distracted by trying to debug his PDP on a chip, presumed. Nothing new since yesterday? No. Yeah, where do you plan to get 600 volts? So, that's the fun thing. I'm not. So we're going to just hope that this one is good enough. I don't know. So, another thing about that device is that the leakage check, we can try this. This thing is slightly broken and it might be modified. This is apparently supposed to be a spring-loaded switch, and it very much is not now. So it will happily output high voltage. I have not actually checked the high voltage output, so that would be worth trying right now. But I was going to demonstrate this. Every single thing that can do, this can do, with the exception of a high voltage leakage detection. So let's just do one quick validation here. So here is the capacitor. We're going to clip here. I already have it all set up. I've already done this, so I know what the results are going to be. And boom, 2 microfarads is actually one of the most accurate capacitors I have ever seen. I don't know about the 2.5 ohms of ESR there. That seems high, but there's also a weird cap, so I really don't know. That doesn't seem good, but I don't know. I don't have another one. At that voltage, it's fine. At 660 volts, yeah, I would think high voltage caps at ESR being high is less of a problem. Okay. Yeah, I was going to run it either way. So we were going to find out no matter what. So, could you bring it up to 30 volt or something on your reforming setup? Just get over that lane idle for decades hump? Yeah, we might do that here. I think we need to do it both ways because it's AC, but here's the other thing. Okay, this is supposed to be a paper oil cap, I think. I haven't actually, it looks for, yeah, I believe it's for starting the AC motors that drive the floppy drives. Pretty sure. Let me just look this up really quick here. Okay, don't mind my totally normal keyboard that nothing happened to. Paper oil capacitor. Okay, so what is this? I'll go over it in a moment. I mean, there's one image that kind of looked like it. None of these other ones really look like them. I don't know. You know what? Let's try this. Start motor, because I don't want to type space. I like how some of these have doohickeys on them, bleed resistors. That's it. Yeah, I don't know. I got no clue. So we're just gonna hope for the best. Rip space bar. So what I was trying to be productive this morning. All right. So I thought it would be really cool and smart and like responsible if I did a thing like this. So I spent this morning documenting all of the microNOVA cards in the that we have with the light box, so that we have really good images of the front and backs, because I didn't take pictures of the backs before. And I went so far as to even light them so that we can, you know, X-ray view. So yeah, that was what I did this morning. Look like flatbed scans. They are photographs done with the Nikon D5300 that I now have mounted way up high so that I can get much better photos. So fun fact, you remember how the arm with the camera on it fell off a couple of times? Well, I didn't, and it fell off onto the keyboard and destroyed the spacebar. Didn't fall off with the camera, fell off before that. So what I've done is I've added turns out there's a 1/4-20 thread hole through the bottom of the arm, and I put a giant washer and a bolt through that to hold it up. So space key is also broken. So the actual key got damaged, but it got damaged in a way where I'm pretty sure I'm going to be able to get away with repairing it. So it'll be back. So here is the space key, and what I've done is it shattered, and I taped all of the pieces back together and then filled the inside with epoxy to try and hold it together from within. So we're not going to put this back on today, and then we'll, you know, probably do this Friday or whatever, and then file it down, because it'll have like, you saw everything? Perfect. Beautiful. Okay, there you go. You learned all the stuff. It's perfect. You have how many Model M's to not replace a spacebar? This is not like a Cherry MX keyboard. I mean, it's literally a Cherry keyboard, but it's a rubber dome, and they're just garbage keyboard things. This is a point of sale keyboard. They are a little more difficult to get a hold of. So, yep. All right. Not super glue. You were the super glue. Well, I mean, in this case, the goal was, since I had all of the exterior frame of the key, there's bits of it that are missing from the center. I mean, they're in that, but you know, I'm not going to pick them out. I decided to just let the epoxy fill the space. I figured that would end up looking better. Anyway, the super glue and epoxy, it's mixed. In the right situations, it's really good. In the wrong situations, it's extremely brittle and will crack apart. And I feel like smashing on the space bar is probably one of those times where it'll break apart. So, nice heavy space bar for proper annoying typing, yeah. So that was actually plastic epoxy. That was what that was. Anyway, yeah, so Helen Croft was saying no electrolyte in this. Yeah, I really think we don't need to do anything to this. I think that it's this thing and it's not going to change. So, yeah. So we'll go ahead and do that. So again, there's no real reason to do, we were going to check the high voltage output. Yeah, let's just do that really quick, because I would like to know if in the future it makes sense to try and use this to reform super high voltage caps. So, when did I get the light box? If there might be a stream VOD about it on the second channel in the playlist that's unlisted, but I built it. I have it'd be annoying to take out right now because it's like just a giant, like one of those willow trees, but like cables that hangs down in this corner down here, and it's behind that. Anyway, it's a television that I removed the LCD from because it was cracked. And then I made a box out of the Dollar Tree foam board, and the television reflects and bounces off of the white foam board, and it scatters in a way that basically makes a perfectly diffused light box. So, yeah. So yeah. Did you see video Discord server, essential oils, diffuser decorated? I've seen that a couple of times. It's been around for a while. Also, I should mention, grease weasel hard sector. So there is, in theory, an option to convert disks with hard sectors in the grease weasel. So people kept linking to GitHub issue 339 for the grease weasel, saying just do it with a bunch of revs. That's not what they were saying. That's not how you do it, although it may be how you do it. What they were doing was trying to get any kind of read off of the disk, and they were using a ridiculous number of revs. I think Keith said I'm sorry if I'm messing up your name, like to do 72 revs or something, because the goal was to do every single time an index pulse came around, just treat that as like a new track. So many revs all at once was how to do it to make sure it read all the way through. So like default, I believe, is 3, which would mean it would read the first 3 sectors and then stop. So that's what the directions there were trying to indicate. But I did find a commit a little before August 22nd when that issue was closed that said that hard sector support, or initial hard sector support, was being added, but it looked like it was only in the convert mode of the Grease Weasel software. So I don't know if ripping a disk that's hard sectored with multiple revs and then trying to convert it is the way to go, if it's going to read the FM, MFM sector header information and try and rebuild the structure of the disk or not. Anyway, it's really weird, and it's definitely not like fully supported. If it works at all, it's a hack job. It might work, but what I'm probably going to do is reach out to them and say like, hey, how do I do this? I have 140 disks right here of random data that we can try and read first to see if it makes sense that we can actually get something out of it. And then additionally, we're going to rip the boot disk, the one piece of software that I have for the microNOVA, on the imaging once we know how to do it, and I'm going to write it to one of those, and we're never going to put the original boot drive or boot disk in the floppy drives that I'm working on restoring, because there's zero reason to ever risk that one disk. So, yeah. Okay. Let's see. You can't take a flex reading and then try to sort it out later? No. It's just, the only way I could do that is by taping over all of the extra index holes, which, believe me, I have thought about. Because the hardware for the Grease Weasel reports every single sector hole as a full track rotation. It would just be at like 8,000 RPM, as far as I can tell. You have to tell it in some way to ignore that part of it. And it's not really well defined how to do it. So that's the problem. It's because the index, the hard sector index positions are in the same spot as the index 0 sector hole that a normal disk uses. And this disk has a sector 0 hole. It's just a nightmare. So anyway, yeah, there's been a lot of nonsense. One moment here. Or recognizes 2 rapid pulses sector index 0 and either ignore single pulses or record that for sector locations. Yeah, it's gotta be something like that. It is really weird. Oh, those are like 100% it. That's a very good find there, Digital Ice Age. I almost want that. Wow, he's got a lot of them too. He's got 32 of them available and sold 28 of them. Dang. Okay, so if it blows up, it's not the end of the world. We'll be good. Why does someone have it in their cart? Like, you either need it or you don't. Anyway, Basic Colorado 2, not too far. Well, I mean, it's not like I'm really worried about one of these getting shipped. So, try one of the random data disks with the CryoFlux. They say to support it. We can do that too. I need to refamiliarize myself with the CryoFlux because it's always weird. Maybe it's finally time I learn to use the command line, because it would take me about as long to learn how to use the weird Java GUI again. So, why is the CPU apparently never reading from memory? This is nonsense. I will not have. So Ben, you're not in the Forgotten Machines Discord server, so there is a small amount of information that you are potentially missing. If you didn't catch it on the streams, there are cracked solder joints on the CPU card. And if this floppy drive stuff I'm doing doesn't fix it, I'm going to go on a tear and I'm going to solder everything that looks even halfway suspicious on the microNOVA card, or CPU card, which is why I wanted to very well photo document everything, because I am now working towards potentially modifying them, which I don't like, but that might be the only way to fix it. All right, let's check high voltage instead of just yapping for 20 minutes. I don't think we checked high DC voltage. If this was modified and the spring removed, that will actually benefit me, because I do want this as a DC high voltage power supply. So I'm going to ask a question that's definitely one of those things I could have just Googled and not sounded like an idiot, but instead I'm just going to ask it that way, because I'm pretty sure someone like Helen Croft will just know this. Is there a way I can parallel or series MOSFET transistor nonsense to be able to support higher voltages than they are rated for nominally? Because I'm thinking that I might want the ability to do that when I make my amplifier box for the signal generator, to use with this as well, and have one of these power supplies drive the base of the transistor or the gate, whatever, and then have this be the actual supply so that I can have a programmable 450 volts, or is it 350 volt? 450 volt, you know, like programmable power supply. So, series of headache, you need to level shift the gate base. Okay, so not trivial then. So RG beater, I want to do that very badly. That is the entire goal of the Floppy interposer project that I started a little while ago. But that got derailed because I just got other things I gotta do. So, okay. 1K MOSFETs are only a few dollars a mousy DigiKey. Oh, well, in that case, we'll just do that. How about high current? Like, let's say 1 amp. Like, can I do, I mean, I know that'd be 1,000 watts. That would be insane at 1 kilovolt. But what about that? Anyway, power doohickey, gets power. We flip on over leakage mode. We do, whoop, we gotta go here. Okay, so do we get voltages? Why is it negative? It is negative. That's super weird. Why is it negative? Is it reverse bias for that? They have those? All right. Okay, 240, 350, and 450. Beautiful. That's the highest voltage I've officially ever measured on this as well. That's kind of cool. Center is plus, outside is negative. I kind of hate this thing. It's real weird. The Magic Eye is super cool. I just wish I had more reason to like actually use that. All right. Okay. So we could use this for reforming super high voltage capacitors in the future. So there is that. That's so weird that that's positive, but whatever, fine. I'm gonna label that actually. I don't particularly like this solution, but I 100% will assume that common is negative in the future instead of positive, and that's really weird. There. 4.7K, 2 amps for $90. Wow, that's a lot. Okay. So it should be possible. I would just like to build the one box to rule them all that I know I can run anything through. Like if they even just sold like a, you know, an evaluation kit for that MOSFET, that'd be kind of handy. MOSFET would be better than BJT as well, because I would prefer to not have current go through it, especially when I'm using the signal analyzer, because that thing's not going to be able to output a lot of current. So 1 kilovolt, 3.1 amp on DigiKey. Okay, yeah, we'll be super good then. I really only need like 1 amp. Okay. I think we're calling them all done, because we can't reform that. It's just not how that works. Those are all reformed and discharged, so I think we're good. We're ready to go. All right, I'm going to be slightly more annoying this time around because I think I'm going to take some photos of stuff as we work. So, yeah. This feels like one of those things that's a good idea. Although, you know, maybe I can do it with my phone. That'll be fine. I was going to say, let me use a big camera, but, you know, like, why? These are just more like, this is what it looks like for a reminder later. $1.17. Oh, that's gonna be cake then. Yeah. All right, so I'll just have to define a MOSFET driver circuit thing. So switching high voltage. So it's not switching. I need to control it analog, basically. Think of it this way. I have the 450 volts output from the capacitor checker, and over here I have an HP 3325B signal generator. I want to be able to output a, let's say, saw wave, all right? Well, that's gonna sound like switching. Well, I want to output a sine, I don't know, I want to be able to output a wave from that and then have it go to whatever voltage driven by the other power supply. So if I want high power, it'll be driven by like my 6633 or 6622, 32. But then if I want it to be high voltage, I'll use the cap checker thing. My apologies about that. Wesley, thank you for the 33 months of Prime sub, though. But yeah, anyway, well, that's a bridge I'll cross later. Okay. Let's do some filming. I am having a very, very difficult time with the current light arrangement here, and I don't know how I'm going to solve it. It's like, this angle, you know, that's the angle that I film at, but bounce this, there is a light right there. So there is always a light directly behind the camera, and it's awful. I'm wondering if I should, maybe I should move the light over there. I would need some kind of fill light there. I don't know, man. This is bothering me. Old cap checker can only supply a few milliamp anyway. Oh yeah, for that, but the more pressing point of the device that I want to build is to be able to use, say, the 5 amp output for the 6632, but I don't know how many amps I want, man. Maybe I'll look for a 500 volt. But anyway, I want to be able to supply more power from a power supply than the signal generator can output, because that thing is going to be like a couple milliamp itself, and I want to be able to amplify that and have more power behind it. Anyway. All right, enough of that. Done with that topic for right now. Moving on to this, and I'm recording. Okay. I've gone through and I've reformed these 3 capacitors. This one I've determined is some kind of oil paper weird cap that I can't reform. It's AC, and by can't reform, I mean it doesn't need to be reformed. It doesn't work that way. So that one I didn't even need to remove. These have all reformed and passed super duper well, but I'm particularly interested to look at the voltage rail that this one is on after we power this up. I want to say it's going to be 32 volt rail. So I'm really curious, although being for 8-inch floppies, it might be 24 volts, but you know, I'm just curious to see what the rail is on here, because the resulting graph from it noticeably changed at 32 volts, which makes me think that this thing was held at that voltage during operation. So I'm just kind of see for reinforcement of how the whole process works. But this is all done, so we're ready to rebuild the power supply for the 6039 here, and maybe fire it up and get the Nova to actually recognize something. All right. Let's rebuild this sucker. Where did all the screws go? DG floppy. I could get an audio amp, but I really don't want to have an audio amp. Just want it to be a nice little linear thing that I build myself and just have. So this is not, there's positive. Okay, it is labeled. I did also, of course, tape label it, but you know, just curious. While we're doing this, bonus stream-only content here. Well, I mean, it's not actually technically stream-only. If you're in the Forgotten Machines Discord server, I did just post about this. I haven't looked if anybody responded yet. I don't know what happened to the serial card. Look at that. Look at that edge. It's all shiny, and I don't know why. This is not the card I cleaned. I don't know what happened there. I'm a little nervous because there's 3 capacitors over there. I have zero clue of what happened. I really don't like that. None of the other boards look like that either. My original old photos of that card don't look like that either. So something has changed. This part's going to be boring because we are just rebuilding the power supply. We're going to turn it on too, which is also going to be kind of spooky. All right, now for the nuts that I forgot to like set aside the drivers for. Don't remember what sizes they were because I cleaned up to take the pictures. Not that one. Didn't I remove some that were small? Not that one. Okay, maybe none? Use this size? Okay, then I can put that back. Oh. Yeah, close enough. Okay. I think I saw the thumbnail for Epitronic's video, but I have not watched the video. I'm gonna guess it was the main cap. I mean, it's got to be that. In the pet, it's not like there's other ones. And that they did not reform it. I will say, knowing what I know now, there is zero chance I would have turned on my pet like I initially did. Because I did just plug it in and, you know, YOLO'd it. That was dumb with that super giant cap in there. Makes me nervous about powering up my own pet, even though it works fine. Yeah, I think as long as the cap has had a chance to reform recently, it should be fine. You know, it'd be cool is if I actually put the washers on here. Was a DC capacitor. I am not intimately familiar with the construction of every pet, but I know on the 4032 that I have, there is 1 or 2 large, I don't think they're sprogs, but they look like sprog compulytics. They look like these, that are mounted, towards the keyboard area from the transformer. Do 100 volts at 5 amps, radiation hardened. So one of the reasons, this is why this is complicated, because if I encounter a really high voltage cap, I would like to be able to use the cap checker condenser thing as the power supply, but then I need a way of modulating the voltage, and using the other programmable HP power supplies to the gate of a MOSFET would allow me to do that. So that's why I'm thinking like that. Didn't reform giant soda can cap in 8032 and powered up just fine. Say giant isn't that big. I mean, yeah, that one, I know how big the caps are. You know what? I'd say they're about maybe slightly smaller than the body of the handle here. They're around that size. Okay, this one I'm gonna just. Okay. Because this thing rubs against so many parts in here as it gets reassembled. I don't want it to blow anything up. You know what would be smart is if I hadn't reattached this first, because then the plate and the... You know what, I'm just doing it. I'm backing out the screws on the big cap. Because that'll let this flex a lot more. Short cap. Just grab one to be ready. Oh, it's going to be so much better. Okay, positive, positive, blue tape, blue tape. Oh my gosh, it's such a pain to move. In position, okay. Just don't ask the price. That reminds me, I need to email back Thor Labs and get an actual reading from the spectrum analyzer. Oh, I didn't even attach the weird clamp thing. I feel like that could crush the can, so I want to be careful with that. Okay, I'm going to remove the pieces of tape as I go along because I don't want them left in there indefinitely. All right, tall one. They really wanted these things secure. They got a washer and a lock nut and the retention clamp that goes on the other side. Done on the back side. At least for reassembly, there's a couple of things I'm going to measure. Stop it! Come on, thread. There we go. Oh yeah, all the black screwdriver on the tip is screwed. All right, now the weird one. Man, if I think this one's weird, I wonder what kind of crazy stuff there's going to be in the hard drive. Oh, the paper actually helped. I was about to put this on backwards. And by paper, I mean tape. All right, that is the power supply fully reassembled. I mean, you know, the power supply, not the floppy drive, but the power supply fully reassembled. Let me torque down all of the caps one more time just to be sure. Then I think we fire it up. Anyone want to try and convince me to use the, you know, I'm not even gonna offer it. What's the point? Okay, everything is ground on that side. And then there's 3 giant bus bars here. You know, there is a power switch on this thing. So I'm gonna have to drag the entire unit over here to actually turn it on. Has to be put on those. This is gonna spin the floppy motors. There's nothing I can do about it. Okay, I had to bring the chassis back over for the floppy drives because there's a power switch in the front, and that'll all be part of this connector, which operates the mains voltage stuff. Unfortunately, what that means is that these will end up spinning. Well, I mean, maybe, you know what, I could just unplug these. These are the motors for the floppy drives, and they will operate at mains voltage. You know what? No, I'm just going to leave them plugged in. They either work or they don't, really. It's not like I'm going to tear them apart and service them right now. But these are going to spin because they're going to get mains voltage, but we'll have all of the logic disconnected, so the heads aren't going to move or anything like that. I've never heard of a power supply that's damaged from not having load, but it may not bring up the voltage rails correctly. Okay. Let's just remove that. Move this last piece of tape here. All right. I think we're ready. I'm going to do one review of old photos just to try to visually confirm it all looks correct. So the label should be here. Labels are just not visible, although there should be like a black mark on the top. There it is. The GE thing, yep, right there. And to the outside. Little stupid one in the middle that you can't see at all. Okay. All the polarities look good. I see no reason not to power this. This sucks because this thing is such a pain in the butt to unplug. I really don't want to plug it back in, but I have no choice. All right, how does this go? There's the key. Ugh. So awful. DZAC, thank you for the gifted sub. I don't know what the deck talk's problem is. There. Okay. Front panel switch is off. Power strip is off. Power supply is plugged in. The only thing we're going to immediately see is fingerus chopperus turn on there. Other than that, we'll have to break out a multimeter to measure rails. Okay, here we go. Power strip on. Flipping the power switch for the power supply. There the motors go. Oh, those cleaned up well. Oh, that sounds really, really good. So, 8-inch floppy drives constantly spin the motors. Those sound fantastic. This didn't explode. I like that too. All right. That's pretty good. T2SDE and Raiders, hello and welcome. You just observed the first time that this Data General power supply from like 1976 has received power in probably like 30 years. So that's pretty sweet. Yesterday we reconditioned the capacitors in the power supply and it looks like they liked it. We're now gonna do some diagnostics on it before we plug it all back into the logic board here, which this logic board, here's a ruler, all right, just for, here's 2 rulers for a sense of scale, okay? This ruler does not go all the way to the front of the case, and one ruler isn't enough to go all the way across either. That sucker's massive, so I'm hoping there's nothing wrong with it. But yes, oh my gosh, that's excellent. Okay, let's do a voltage measurement really quick here. I could drag it over to my bench where I got all my fancy stuff, but it's also giant and heavy. So, all right. It works. Okay, so we're gonna do some DC voltage measurements here of the power supply just to see how everything is looking here. So, I'm gonna turn it on again. Oh, that's so good. Okay. So we have ground here, and then positive on that. 24 volts, okay. Interesting that it was reformed all the way up to 32, but I called that rail. So that's looking fantastic. Then we have ground here and positive. 8 volts, okay. Then we have, I have no clue on this one, everything's on the front. 5 volts, looking pretty sweet there. Okay, those are probably the 3 main rails. That's looking good though. Ben, thank you for the 100 bits. I don't know what to do here. I'm going to try to force a buffer size of 128. We'll see if that does anything. But thank you for the 100 bits. Whew. Probably decommissioned in the 90s. So the service records for this thing go up to 89. They might cross over into 90. So that's what I mean by 30 years. So, oh my gosh. Super short glass fuse. Yeah, Data General apparently loved those. It's looking good. Okay, so now the actual output rails go here. Measuring those is a little trickier. I don't know how I want to approach that. I don't think I'm gonna bother though, because everything there looked really good. So I think we power the logic in the drives. I think we're there. I think I plug this connector in to here and we see what happens. All right, I'm gonna fully flip this around since we know the power supply is probably not gonna explode. Ooh, you know what? Actually, change of plans. Before we plug this in, we can get an idea of what the rails are by looking at this connector, and we can check for shorts on the logic board before we apply power to it. And that feels like one of them, you know, probably smart things. So just to double check that I understand ground. Cool, okay. So this is something. Oh, I don't like that. And then this is something. And then this is something. That's not cool. So on here, I just want to see if this stuff's still charged. It probably is. No, wow, okay, smart. Okay, so this is 5 volt. Ooh. Yeah, I believe that was... Okay, so that's the same. Hold on. Oh, I fully unplugged it. We might have a 5 volt rail short on the logic board. And if we do, I have no idea how we're going to find that. Ground to here would be 5 volts. Man. Okay. All right, we're now entering into the realm of extremely bad things. Yeah, we might actually do the glow test for the first time here, which is going to kind of suck because I got to set all that up again. Oh my gosh. This is what I was saying. That light is a blam right there. It's so bad. Okay, we're gonna go back to a beep test here real quick. I am putting on my ESD strap for this too. So, ground to ground. Yep. And then cap. That's not good. It says 15 ohms. Gosh. It is. That's so bad. Man! That really sucks. There is so much here. Wow. So just to finish the diagnostics here, let me just hold that there. So this is shorted, not shorted, not shorted, not shorted. Okay, so only 5 volts is shorted, which probably means, I mean, yeah, that will mean, oh my gosh. Ugh! This drive is from 1977, by the way. Yeah, I think we're gonna have to do this thermal camera. 5 volts, 15 ohms is only 330 milliamps or 1.6 watts. A lot of logic on there, so that may be fine. I don't know. I do think this is a power supply and slow bring up with thermal camera moment, though. Let me get that set up. I think it would be irresponsible to try anything else. Now I got to figure out where I put the thermal camera arm. It's not that. It's not that. So here's the thermal camera. One way to find out, send it. If half the chips didn't say DG and have like weird part numbers on them that don't match to anything, I would maybe be inclined. But because I might have to actually build a logic chip to replace those, I'm not super keen on the send it methodology here. I have no idea where I put the thermal camera arm. Oh man, come on. It was on a webcam. Webcam. Program a gal. Yeah. Weren't gonna kill a chip with that. I could. If the power supply can provide like an amp and then it just rips through it, it could kill it. Whoa. All right, you know what? I'm not gonna drag this out this much. I'm just gonna use the phone. Continuity test, only see power draw on logic chips if put enough voltage into the chips, turn on the transistor junctions. That feels like a good point, but I'm not 100% sure. You know, everything was before you cleaned up? I actually did. It was on the desk over there. There's one spot it could be. I'm gonna go look for that. Because I moved. No, it's not there. Yeah, I did actually know where it was before. I really genuinely did. Okay. So, I'm only thinking that's ground. This could be ground. Neither are ground. No, I don't know. Was he debugging? I'm getting a 15 ohm short between 5 volts and ground on the board here. It's very solid. Did tantalum exist in this era? Oh, I am not sure. All right. Let me pull this. So it would be we can do it that way. Well, serious, 15 ohms is not a short, it's just 330 milliamps. I'm seeing something like 75 ICs on the board. Yeah, no kidding. Actually seems low for that amount of logic. Well, I will slowly bring it up and we'll see. And I'm going to do that externally. Okay, so that is 5 goes to, that's obviously not going to work. Okay, that's not connected. That's the second one. Okay, that would be ground. So 5 on top, ground on bottom. Okay, so that's actually 5. And that's actually ground. Okay. Deck PDP can supply 120 amps. That is a number of amps. All right, here's how we'll handle this. 50 milliohm increments, and if it does not go past 350 milliamps, or we'll bring it up in 350 milliamp increments. If it does not go past 350 milliamps, then I will just plug it in. To the main power, but we're going to slowly bring it up on bench power first. Pull something like 3 amps. Oh my gosh. Well, we'll see if one part in particular starts heating up. How about that? Any markings on the PSU? No, I couldn't even identify the 5-volt rail without just measuring it, actually. It's really bad. PSU board sucks on this. The only marking it has is the far side of the card edge connector is pin 10. That's it. Okay. We're going 33. And I am actually turning it on. I'm setting VSet 5, go. That's 5. I set 0.1, go. Okay. Off, on, okay. Output off. Okay, so positive, negative, going to a leg of a capacitor. Okay. Is any caps exploding? Nope. Okay. You know what? I can't actually start the GPIP overlay here. What do you mean, no such device or some or another, GPIB? Failed open device, GPIB 0. Do I need to do the GPIB config thing? I don't think I need to. I think it's in the, what you call it, udev. Failed open device, GPIB. Okay, what gives? Did I accidentally unplug it? I don't think I did. No, it's plugged in. Okay, well, we're not going to have the GPIB overlay. All right, thermal camera, phone. Don't want the kind of pointless macro adapter. All right, here's how we're going to handle this, okay? I am going to watch the board here, not from that angle, because you're seeing a reflection of the light from my fluorescent light there, but closer to around this angle. If any one part becomes anomalously hot as I bring up the voltage slowly from a bench power supply, I am going to shut it off, and we're going to have to figure out what the shorted part is. But if it seems like everything is heating up evenly, we will continue. So we're going to go ahead and do that, expecting... Wait, what? We're expecting negative voltage for bias, and we're going to have single rail contaminants ICs. Dude, this is why I always tell everyone, no, we're never doing this. All right, screw it. Send it. We're never going to use the thermal camera to temp check ICs. Because that is exactly my concern. Send it with thermal view? Well, but now I just threw the camera across the room in frustration. Beginning. So we have 24, which is expected for the 8-inch drives. I measured an 8, which might be 12, but not loaded, so that kind of seems fine, and a very rock-solid 5. There's a 4th pin that I didn't measure on the power connector. I don't know exactly what it goes to, but it's probably okay. I don't know. I didn't notice a negative rail, but that's not to say that they're... I mean, I don't see anything to generate a negative rail. I don't know. We'll attempt to use the thermal camera in my phone cage thing. I don't think it'll reach. No. Okay, one Type-C extension later. Annoyingly. Oh, wait, I could grab. Would that reach? No, that will not reach. I need to buy some more Type-C extensions. They're shockingly handy. Well, now this isn't going to stay up here either. It's like, what's the point of even having the phone in the thing? 8 volts is an interesting one. I suspect that it's an unloaded 12. I'm not reading too much into it being 8. This is not going smoothly because it's not held correctly to the phone now. Now, what if? I have high res shot of the board, sync some of the ICs, or probably in the IC manual. I can get a high res shot very quickly and easily now. I destroyed the spacebar on my nice keyboard getting set up for that today. Oh yeah, here, let me just reach here. I'll even disable that. Reach up here, whoop, flip around my reference camera now. Heavy computers and heavy computer things. Well, it's more that the arm that camera's on fell and it just completely clobbered the keyboard. Oh, that'll work. Okay, so let me do this. Come on. There we go. Now that's good. Okay. Let me stop recording. Okay. So I need to turn the camera on. Fire up and tangle. Pump this off to the side. Give you all the view. And here we go. So photo mode. Oh yeah, the white balance is going to be all sorts of screwed up because my light panel that's using to take the PCB shots earlier is very blue balanced, but we can go ahead and use that to try and light this a little better. So you guys are getting to see the light box set up, even though I said I wasn't gonna. Here we go. Because I do want a nice photo of this. So there's that. And then the secret sauce on broken television. So from the back here, I've got that. I'm going to take the TV. I'm probably going to have to hold this because I don't think it'll reach, but I'm just going to plug it in. Boop. And it automatically will turn on. Beautiful. Now I'll just arrange my shot. Oh, big PCB, man. Yeah, it's not going to be rectilinear, that's for sure. Stop tilting weird, camera. It's such a big PCB, man. And the arm does not want to cooperate. Hold on, you know what? Rotate it out. That'll help. What's it hitting? You know what? Just go on the keyboard. I don't care. Okay. Now, there we go. That's better. Doesn't need to be perfect, but it needs to at least be workable. Okay. Now, and that. Okay, how's that looking? Okay, I'm going to hold this up now and retake that. There. Might be better. Pictures, capture, not screenshots, capture. Oh my gosh, don't open 30 times. No. Okay, white balance is going to be all kinds of messed up. And touchscreen. Oh, I think I know what happened. I added a second monitor over there. Okay, it's a little dim, but I think that'll work. Okay. I will make not that, this available. That. Oh my gosh. Screw it. Oh, I was not set up for that. I made the TV light box. There's a stream about it. But literally take one broken TV, remove the LCD. Now you have bright TV. Okay. What was I doing? Oh yeah. Okay. Image. All right, you have the photo now. Okay. Okay. I think we basically determined we're just gonna YOLO it. Try to identify some scary ICs. All right. I am going to do this, though. I'm going to measure ground and 5 volts with the fluke as this thing is powered up. Actually, I'll explain this more in a second. I'm going to go turn off this light. It just has to be. How is it still reflecting? The thermal camera is still seeing something. All right, well, then turn the light back on, since apparently it doesn't matter. What if I put my hand in there? That's so annoying. That angle is better. Okay. All right. Okay. After looking at it a little more and being pushed, namely by Usagi, yet again, he's in chat watching as I work on this live, we're going to go ahead and power it up with the original power supply because 15 ohms may be the kind of load that this thing would just actually have. So it may not be a short. It's not a dead short, so it is 15 ohms. But yeah, so just for kicks here, if I go over to ohms, I am on the 15 volt rail here, so or the 5 volt rail. So you can see it's a 15 ohm load. So here's what I'm going to do. The power on the unit is off. The power on the power strip is off. I'm going to be holding the power strip. If it goes up in smoke, it's not my fault. Oh, okay. I'll be holding the power strip. If this droops significantly, I'm cutting power as fast as I can. I am also now recording thermal camera footage, and if any one part seems like it's becoming abnormally hot, I'm cutting power. But here we go. We're going to turn on the whole thing. I'm turning that on because I'm just going to turn it on from back here. You know what? You know, it'd be really, really cool. There we go. All right. Here we go. It's looking good. Parts are warm. They're not excessively warm. I have 2 right lock LEDs. There's a very high-pitched whine. I think we're good. Okay. Chalk 1 up to learning. I don't know what the high-pitched whine is. It's really bad, though. All right. I'm going to stop thermal recording. If the whine is coming across in the video, there's nothing I can do about it. Okay. Let's check the other rails. -5, okay. So possibly a good thing we didn't power it up. 24. 5. Okay. This might be a functional floppy drive. Whoa. Why don't you use a button on the power strip? I did. I was holding this. Unless you're talking about the like weird UK ones where they have one for every single outlet, in which case those just don't exist in America. Oh, all right. To give you all the fun of it, here it is turning on from the front. There you go. We have the lights there. All the logic does seem to be working. It's a DG color scheme because it's a DG. I don't know why they say they're not, don't say they're ready, but interesting. We can try a thing. Actually, I need to confirm something first. I have 8-inch cleaning discs here. I need to know if I need to use these single-sided or double-sided cleaning discs. So let me try and determine how many heads this thing has. Single head for sure. So we want to use this disc type. I'm going to pick off that fluff. I'm going to wish I could remove the media, but I can't. So here's what I'm going to do. It will spin. I don't know how it loads, but I'm just going to pop this in here after spritzing a little IPA onto it. Oh, come on, work with me. Okay, so now we're going to try and clean the drive. I don't know how the head load will work, but this should do something. I saw the ready light flash a couple of times. I can't pull this back out. So that's okay. Interesting. This, that goes in weird, man. Ah, there we go. It's flashing ready. I don't know why, but there we go. Okay. That looks fine. Same behavior, it looks like over there. All right, oh yeah, door's metal. Okay, we may have just cleaned the heads. Maybe. I kind of wish I could see more. Look at the dust it deposited on the corners. The tink tink. You know, I don't know what the sectoring is like on this. Okay, this is a soft sectored, oh, kind of. It's got double holes. I don't know what the deal is with this. What if I put it in like this? Really wish I could see the head, if it's actually pressing down or not. I do not believe it is pressing down. So this is only clamping the hub motor. So we haven't actually cleaned the heads. Because I can barely see the top head through the crack in the door on the side, and it does not move. So I can see right now it's not down, and then barely down more. It's definitely not moving enough. So we're not actually cleaning the head, but we are spinning the disc, so that's good. Both sides spun. That's a good sign. Yeah, but we can't load the heads knowingly without something else, and that something else is the computer. So, needs head load signal from the machine. Yeah. All right. So there are other problems we don't have solved, like what the drive ID is. I have literally no clue. None at all. Powering on with disk preload, make the heads clamp onto the disk, at least temporarily. I don't know. Doesn't hurt to try. At least I think it doesn't. See if it sounds any different. It goes in a way I really, really don't like. I think it's one of those drives that wants you to click the disc in, but then the cleaning disc kind of sucks. That didn't really sound any different. Yeah, we're gonna just plug it into the Nova. We have a lot to set up here. Actually, really quick, how much power does this thing use? It's probably using the majority of the power it's going to at idle. Oh my gosh! That's 225 watts to just sit there. That is one of the other many reasons why I have never tried to do the data general stuff. It takes lots of power. I'm going to plug the Nova and that into the same circuit. The dasher will be separate. Not Energy Star rated, yeah. Okay. Let me grab the computer. So let me put down a pad for the computer, because the computer's dumb. I need to check the rotating lock switch before we turn it on, because my hand slipped when I was carrying it, and I felt that I brushed up against it, and I need to make sure I didn't damage any of the stupid little delicate wires that are all dying in there. So let me do that first. Looks good enough. Okay, so currently we have the CPU card and the console debug card in, and that's it. We'll have to go make launch while you do the tedious setup stuff? Okay. I need this. And you guys are getting a bonus view for stream, because I need a camera around the back and there is no way I can get the black magic around here. All right, we get to utilize something I don't get to use too much on stream, so that's fun. Because I was sent the super cool HDMI output device for my camera to allow me to use Blackmagic for recording. And this is one of those times where it's going to be a lifesaver. I'm going to steal the Dell power supply from over here, though. This is a very tedious setup stage. Now that I think about it. Because you guys need to be able to see and understand what's going on with the cables and terminator and stuff, and that's just going to require many camera angles. Shut up, phone. Okay. Disable DeX, open Blackmagic app. I said open Blackmagic app. Blackmagic app keeps closing. I don't know, close app, open. There we go. Okay. So now, do you guys have camera? Boom. Not that one. Boom. Yes, that one. Perfect. Okay. Because I can go, look, it's a Terminator. Excuse me while I drink yet more coffee. Whoa. Speaking of Terminator, we try 1024 refreshing that. I think I might just have to go turn it off and on again. But HashiTube, thank you for the Prime sub there, and for the first time. Well, Usagi, you got to think, I'm going to have to do that 1.2 kilowatt or whatever it is on outlets, like regular, not like household, but pretty much household. I don't have 240, I don't have high current, so it's not going to be trivial. Okay, I don't know why this is so terrible. PS 60, much better. I think I had a LUT. Rec 709. Why does it look so awful? LUT selection. Phone LUT camera. No phone LUT. Oh, what on earth? Monitor. Yeah. LUTs. Display LUT. Okay. That is better. That'll work. Okay. My balance. 56. Okay. That'll work. Slide this over a little more. Perfect. Okay. We're almost set up here. I'm going to go restart the audio interface. Just to maybe fix it. I need to wait for it to boot though. Then I have to do some routing over here. Boop, boop. Okay. Maybe it's better now. Okay. Does Blackmagic app allow log recording? We'll get log video the next Android version. Ooh, I don't know. I was gonna hate the next Android version for a few reasons, but that sounds awesome. Okay, well now I'm excited. I have no idea. Currently it allows you to record in Rec 709 and HLG something or another, but if you record in the HLG one, then it like sucks and it has frame pacing issues, so I don't use that. What's wrong with the new version? It's just the usual thing. Lots of little changes for literally no reason that just don't make life better. That's all. All right, one dasher terminal coming up. Oh, it's so heavy. It's so heavy. Oh my gosh. Now I see why Severance made them weird and narrow. I just wanted to make them lighter. Ugh. Alright. Keyboard. By the way, you guys haven't seen the keyboard connector yet. Just that's the keyboard connector. Why? Why is that the keyboard connector? Why? Apparently the printer connector is the same. I don't have the printer option though, so I wouldn't know. So sad. Such a crazy connector. Okay. All right, and then the cable for the data, where it's just kind of all over the place. It's too long. It's literally been cut and spliced. It's not like a good setup with this cable. I don't like it. What are you caught on? Oh, like a giant blob. Okay. It's EIA. Click. Okay. We're getting close. I need Firefox. I need VGA scaler and one, and then I need HDMI switch. Could be had a contract for a lot of those enterprise grade connections. Just used them as much as I could, maybe. 6 here. Okay. Just out of curiosity. Turn that on. And blinky cursor. Oh, you know what? I never checked power on just the dasher. It's not plugged into that, so that makes sense. Why am I not getting video? Cool. I love it when things don't work. One moment. We're going to want video capture for this. So, matrix. No, not matrix. This thing. Scalar. Hold on. I got an idea, and it's power cycle the hard way. I might install a fan in this dasher. It gets warm. Makes me a little nervous. Okay, there we go. Now if I go here, boom. 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 Dasher capture. Okay. Actually, I'll leave that up for you all. Okay. Line. And we're close. We're real close. I think we might be ready here. Okay. I was gonna grab my phone, but it. One moment, I need to look at old photos. I'm gonna look at my old Data General photos because I want to make sure I get the orientation of this connector correct. This may not be the original cable. It's hard to tell. There's a sticker that possibly fell off. I'm gonna go look at the other cable actually, just make sure that it doesn't have it. It does not, so that sticker fell off at some point. Okay, that's fine. Okay. All right, I think we're ready. All right, starting recording on that. Starting recording on, you know, I'm just going to double check that it's actually recording in 4K and all that fun stuff. Okay, there is that. Okay, let's do this. All right, so here we have the floppy drive, the microNOVA, and the dasher. We're going to try and set this up. So there's one thing that I need to do first here, and I'm going to have to run around to the back here to show you. That's the wrong camera feed. So this is what I was talking about earlier. This is the I felt static there when I touched the back plane. This is the terminator that ends the data line. So we're going to have to pull this off. And this will actually be put onto the main logic board of the floppy drive here. So this goes the other way, I believe here, based on the markings or the orientation of that thing. So we put that there, and then we have this cable. So this goes here. And then the other side goes on to the back plane. All right, now the position on the back plane here, this is just so weird. It just goes at the end right here between two cards, and that's it. That's how you plug a floppy drive into a microNOVA. It's the weirdest thing. I'm gonna let that finish or stay recording. It doesn't need to be. But all right, in theory, that is the floppy drive connected to the microNOVA, and then we have the dasher. The dasher is still only connected to the console debug output, but we're not expecting this to actually try to load anything. My only hope here is that we see it attempt to access a floppy drive. I don't know if there's a good way I can get the floppy drive lights on screen for you guys, sorry. This is just really wide. Some of the serial cables connected to DG1210. Well, that makes sense for, you know, them, the weirdos. It's the same weirdos. It's plugged into the wire wrap pins on the back plane. Yeah. All right, so I'm just running through this all in my head one more time. Drive connected to this. This is connected to this. I typed some gook on there so we make sure it's good. Don't worry about that. I'm going to put the cleaning disk into the left side drive here in case it just tries to immediately boot something. So we'll see what that does. Other than that, I think we're ready. So I'm going to turn on the drives. All right. Now I got to find the key. Where did I put the key? Here, key. Come here, key. Oh, I put it, I actually kind of put it somewhere smart. All right. Let's see what happens. It went straight to console. That's different behavior. Wait a minute. Hold on now. Two, look. 1, 2. Ah! Okay. Hold on though. Go back to reset. Run. It did not go back to the console this time. There's a fail. Okay, so that's the same behavior. No, it's Augie. It's just screwing with us. Now it did it. All right, I'm going to fully turn it off and back on. I saw nothing. And then it didn't go into console. Back to console. Okay. Huh. Interesting. Press L. That should have locked it up. Nope. Didn't try and do anything. All right, there's one more thing we can try. I'm not ultra crazy thrilled about the concept, but it's not the worst. Yeah, we need the device ID, which we do not know how to get out of this thing. So there were versions of this drive that had spin wheels here for the IDs. This one doesn't have those. We just have jumpers. And there don't seem to be jumpers laid out in a way where it makes sense what they are. So I don't know. There's a list of defaults in the manual. Yeah, but I didn't see one for the floppy drive. I know what you're talking about. I didn't see one for this. If you want to look, be my guest, though. All right. I'm not crazy thrilled about this, but it's possible it doesn't like the index positioning being wrong. So we could try a real hard-sectored 8-inch floppy. Now, the risk here is that I don't know what's on these. I assume it's customer data, because I would be the luckiest person on the planet if this was 140 disks of software. That's not going to happen. So, yeah, I don't know exactly what's going to be on these. I mean, they're labeled really weird stuff. Like, this was AD space K1. So, yeah, they're not great. This one says advertising list. So, like, it's not... I don't know. But it is possible there could be something on here that I could clobber. This is probably the coolest one, by the way. A blue, hard-sectored 8-inch floppy. Just like what? Active Directory, yeah. So many megabytes, yeah. So, it's difficult to commit to putting one of these in there. Oh, here we go. I like the idea of this one. Bad disk. So that might be our candidate. Okay. I say we try it. All right. Now, I am not expecting this to boot or anything. What I would like to see is how it behaves. Ah, that is different. So we have a solid ready light now. I tried to put the sleeve on here and all the fans are just blowing it off. Okay. What if I run PL start now? It didn't seem like anything happened, but I was also in reset, so that makes sense. Okay. Run. PL start did nothing. Yeah, I'm not hearing the drive attempt to do anything. Try 33L. Okay, if we get back in, I will attempt that. Oh! Hold on. I may have just tried something I never tried before. So, start, doesn't do anything. Continue made the light bright. That's weird. I wish I was on scoping the fill line right now. It is refusing to go into the console. Yeah, it's not going into the monitor at all. That's not necessarily indicative of anything. Watch, it instantly goes into the monitor there. Should consistently get to the monitor. Yeah. Yeah, we're getting close to reflowing all the connectors on the CPU card. Or the pins. Let's try to get back to baseline. And so we can try 33L. I have power reset. You just can't tell because there's too many giant loud fans on. Oh, let's do a power check. 315 watts. That's still total less than the plasma. We effectively have scoped the CPU. We cannot get to the card while it's installed because metal plate. Dead cold boot, hops in. So that's indicative of cracked solder joints, Usagi. A temperature change causing something to expand or contract, definitely cracked solder joint kind of issue. Okay, we're into the monitor. All right, we just got into the console monitor. I'm putting in this disk, and I'm going to try the command 33L to see if it attempts to boot from it. Here we go. I believe that is a no. Initialization. All right, well, that's unfortunate. What do you mean, oh? What do you mean, oh? You know how hard it is to get into the console? And now you tell me it's not gonna work? All right. Well, we probably have the floppy drive up and running now. It needs to be cleaned still, so it's not done, but once I know how to make it spin the disks and load the heads, that should be doable. So it's mostly ready. At the very least, I can power it without concern. So that is a good step, but it did not fix the boot inconsistency. Thought I was hearing something in like one of those bouncing around specific spots. So the next steps are going to be re-soldering chips and pins and stuff on the CPU card to see where we can go from there, because that seems to be a very sketchy, flaky device. All right, I'm recording off and on through this, so that was for that. I will say, though, feels pretty darn good to have the floppy drive at this point. If that giant stupid hard drive wasn't in there, I'd wheel the cabinet out so we could use it more directly, but that giant stupid hard drive is a nightmare. So I don't want to deal with it. I'm going to leave bad disk up front as our sacrificial test disk. Just wanted to even see progress on these. I mean, it's maybe progress. I mean, not blowing up when I turn it on is a form of progress. It's not great progress. It doesn't make me happy, but it's something. We do have to put all the screws back into this, so there is that still. I'm not going to remove that, but I am going to remove this so that I have more space to work on this while I put it back together. Async card asserting fill memory addresses, so RAM's never responding. Testing hypothesis require hooking up logic analyzer to the bus to demultiplex it. Yeah, and resoldering pins seems like the more beneficial thing to start with here. I will get a really nice tight macro shot of how bad some of the pins are for you guys as we reflow them, because some of them are pretty rough. Okay. Case. Oh, stop recording on phone, which has drop frames because, of course, it did. It's supposed to not in H.264, which is what I'm recording in right now, but you know, why would it do the things it's supposed to do? Okay, I'm going to move the terminator back to the back plane. And then we can remove the cable from the floppy drive. I can shut off the dasher. Oh, I love that thing. So good. I don't know if they yellow or not. I've seen some photos of these where they look really yellow, and it makes me a little scared. Mine seems to have survived so far, but mine currently is this delicious cream color. It's not white, it's not yellow. It's great though. The metal pieces of the panel here are painted that color. You'll notice that some of the stuff is white actually inset, but this is painted cream. It's not white. Anyway, I just love this stuff. It's so good. All right, let me get all of this out of here. If you want to make it look very correct, yeah. It's beige. It's not beige. It's different from beige. Yeah. Okay. Proto beige. You can see your Twitch dashboard? Yeah. Oh, well, okay, sorry. Hold on, let me. I was like, I don't really care. But actually, it's not supposed to be up. Okay. DGFLP. Okay. All right. Now that we've got this as restored as we can tell for now, I'm going to go ahead and reassemble this thing so that I can move on to the cards. Oh boy, so much work. Can't believe you just show people's messages like that. Yeah. Gotta head out, back to work, reorganize the entire office. Good luck for sure to you as well. That I don't envy that. And that's basically what I was doing before you got here, so I know exactly what you're doing. It sucks. You need a plasma out there so you can run random YouTube videos while you're working. It'll keep you nice and warm too. All right, now I got to find the right size socket for these. It's not that. Oh, no. Okay, good. The lock nut part thing fell in. I thought I was going to get wedged. Oh, that's the one right there. Gap. Gosh, why they gotta have such a well-managed cable harness? This isn't necessary. Oh, it's weird having the power supply be warm now. Oh, whoops, I accidentally left the server connection on. That's a waste of data. Oh, weird. Floor's clean, so I can actually tell where something goes when I drop it. Oh, this one sucks. Right behind the DC cable. Reassembling? Yes. Not really to impress, more like not unimpress. No, it was just, the rearranging really only started because I got the plasma. That started before we even had the plans for the meeting, or the collab. That's cross-threaded. I wonder where this draws air in from. Oh, no, it's the drives, isn't it? Ugh, gross. Yep. It is the drives. Man. All right, we got this and then the lid. Where did I put the plate?
Plate says CHEER 100. Does the drive have jumpers? W5 TOW10 T hose might set the drive address according to the document. BEZO 1 found. End of line.
So W5 to W10. Okay. I see 1, 11. What document is that? Because I'm not aware of any documents that directly describe this floppy drive. I found 5 through 10. All right, right there. It's gonna be octal, which is, you know, stupid. So it's 5 and 6, so 3. And then, yeah, 33. It's 33. It's what Ben said. microNOVA technical reference. Okay, it is what Ben said. It's 33. You know, I'm not sure. I need to reread that manual. It might need a 4-digit device code. I don't know what you mean W10 sets 0. W10 is currently 0 in data general parlance. So 5, 6, and 8, and 9 are the only jumpers, or the only positions that have jumpers. Let's put it that way. Okay, I need the big plate and I need the lid. Where over here? Yeah, they're over here. Heavy. I'll bring that section up, Ben. There is something about bit 1 being a thing or not. It might be W10 that they're talking about. It goes 10, bit 0, W9, bit 1. Wait, you're saying it's LSB? So if you look at the See, this one Indianness, man. I just, ugh. I don't know if it's gonna be LSB or MSB. Ow. Blood sacrifice? Yeah, I wish. If that was all it was gonna take. But no, it looks like the answer is no. Why are there like different sized washers for this? There's a flag bit if you're stashing device address memory yourself, yes, but it says L command just takes device ID. Okay. I thought it was meant to be 4-digit, or maybe 3, because, you know, octal. And then, I don't know. One of them, like, described how you do it. I don't know. Oh, air may come in through here. Maybe, yeah. Because it comes out here. So maybe it does come in there. That would be really good, because it'd cool the chips. That would also make sense why the board is so big, because they're using it as an air deflector. All right, there we are. So I'm going to put the drive back in the rack for now, and take a look at all the cards. But it does appear to be working. I'm gonna do an outro for a video about repairing this thing, you know, repairing it. So if you enjoyed this look at yet another data general component, that will hopefully be brought to life and function with the microNOVA soon, knock on fake wood, then you may want to subscribe to be notified when I release another video. If you want to help support the channel, you can find me on Patreon. But for now, that's it, and I will see you next time. All right, there you go. Our programmer, it's the end. Bye! No, I'm just kidding. I'm just recording an outro for a maybe future video. Bit 0, MSB, so W10. So read normally from left to right. Yeah. So I had it correct then. It's still 33. Ten, 9, 7, and 6. Well, that's not what it is. Here, I'll just post the picture I took on Discord so you can look at it and decide for yourself. Come up with whatever wild fantasies of how data ordering works. There you go. Completeness. Oh, wait, no, I don't have that. Okay. Okay. Well, thank you, Hammer. All right. 8, 9, 6, and 5. See? Yeah, that's what I thought, and that's what it is. So, okay. All right, back in the rack. Rack's over there. This is right there. This is heavy. Also, this time I have to actually stop and pause and feed the cable through. All right. 4-bit octal. It's 3-bit octal. That's how octal works, because it's 0 through 7. So that's why it's oct, because you can represent 8 possible values. It's weird, man. All right. Yeah. Yeah. Oh, that power supply is so heavy. Get in there, cable. Yeah. Okay. This is not a good position to start from. and in. There we go. Whew. All right. Whew. Okay. Mini break. I need to fetch the macro lens for the camera that fell off the back of the table over there, rolled under the table. Bite break, so a fun thing here, mini story time. I tried to pull out a couple of interesting issues of things, Byte and Popular Electronics. Zoggy came over, and one of the things I was able to pull out was the Popular Electronics issue about the Cosmic Elf, you know, just as an example. So I thought it'd be really cool, like, oh, you know what, I should bring up any of the Byte issues that talk about the Centurion. You know, that'd be cool. Not a single thing is said across all of Byte or Popular Electronics that meant even once.
100, so is this working today? End of line.
Coder Joe, it is indeed, and thank you for the 100 bits. So it's weird. Not anything, nothing at all is mentioned in, especially Byte, I would have thought would have mentioned Centurion at least once. I mean, they didn't have a heavy focus on mini computers, but it was something, you know, around that time. So it's just kind of strange. I have a feeling I should take a sip of coffee here.
Kadershi ER 100.
Nakarataku Tokimo Nakademo Kazarusaka or Guru Guru Mawate.
End of line.
Coder Joe, thank you for the 100 bits. Oh, man. I had populating Wikipedia article for Centurion Company to future-proof it from deletion. Had a heck of a time finding sources. Yeah. Also, they're ruthless on Wikipedia. It's so annoying. I forgot what I brought up to your attention that was deleted that you were fighting someone over. It's like even Jonos has more information, it seems like. All right. I'm going to get some water. I'm going to crawl under the table and grab the lens, figure out the macro setup. And then we're going to start soldering cards. Whew. All right, well, drop the lid. Don't worry, it landed butter side down. It's all good. All right. Hey, nothing exploded in the floppy drive. That's a pretty good bit of progress for today. All right, let me grab the lens. It rolled somewhere very inconvenient. Oh, it's so difficult to get to. Basically, everything over behind the monitors I look at while I'm streaming is impossible to get to. And the lens rolled right back there. Come on. Yeah. Got it. Yeah. Okay. Now I need the macro ring, or the Nikon F micro 4/3 adapter if you want to, be proper. I have two of them. One has a lens, and that one is on the camera that faces towards the desk. And then there's this one, which is empty, which makes it a macro 2 addition to a lens adapter. So the zoom is insane, especially when you couple it with the fact that I'm using a reversing ring on this lens. So we just get stupid macro out of this. Okay. I want the silicone pad, and I want to clean off the soldering bench because that's where we are about to be working. Let me get some stuff out of the way over here. Ignored lens and thought, oh, cool card calculator. Yeah, don't have one of those. Data journals, DGL programming language. One of the few. Can I rescue? Wow. Stuff like that. Yeah. I mean, that's slightly niche. I could see that maybe being incorporated into the main Data General article. But yeah, it can't just be deleted. All right, here's the key. I'm gonna put the key back at the same spot so I can forget where it is later. I am really tempted to put the big shop light back up for this, but I'm going to go without it and just hope for the best for right now. It's slightly dim over here, which is going to be real hard for the macro stuff. You know what? No, we're going to use LED. Let's do this. Let's add a secondary light panel for macro specifically. There we go. Pow. Okay. Backplane extender from HP equipment work on the microNOVA? No. I mean, at the very least, I doubt it significantly because you have to match exactly the card edge connector. Plus, the Nova essentially has dual card edge connectors. They're not the same number of pads, and then one of them is how you get serial out. So you either have to extend the serial port all the way through the machine or just have it connect somehow in the front, and that's going to be ugly. And I got to be honest, if I am designing a thing, a backplane extender, I'm going to do a real fan, have it all poke out so the card can be supported, because I don't want the card just flopping around and like damaging stuff. So I don't know exactly how I'm going to handle it. Okay, so those bits that I just chucked out, I need them back again now. All right. Yeah. Oh gosh. All right. I'm just going to treat this like I am starting yet another video because I'm recording everything that happens as far as data generals are concerned. I'm not going to let anything be missed. Oh my gosh, these drives are like over half full. Okay, I'll be more judicious about what I do and do not record. All right, here we go. Welcome to the next episode in the continuing series on trying to revive my Data General microNOVA mini computer here. In the last episode, we finished refurbishing the 6039 dual 8-inch floppy drive that's down there in the bottom, and it did not let the machine initialize its boot process correctly. To summarize the issue, we have two issues actually. One, when I turn the key over to run and press PL start, it's kind of a gamble whether or not it actually loads the console debug menu that should allow us to load in software and begin using the system. But the other thing is even if we get into the console debug menu, we can't write to memory, which doesn't make a lot of sense. We absolutely should. I can write to the internal CPU cells, and I can even do arithmetic in it, but I can't write to direct memory. Now, the current configuration of the machine is just the CPU card, which has some onboard memory, either 2 or 4K, I think 4K, but I'm not 100% sure, and one async card that has the console debug ROM on it that allows us to actually load that. You could configure this machine without the ability to use a serial terminal to enter in program data, and instead you would have the hand be essentially a calculator and a ribbon cable that would let you enter in hex data to boot the machine from. So today what we're going to do in our next attempt to fix this machine is pull out primarily the CPU card here and take a look at it for bad solder joints, because I definitely, when I was looking closely at it, and I'm hoping maybe this time that that'll be the solution to get it to boot consistently and let us write to RAM. Lettuce. Okay. Let's continue. You're brimming with enthusiasm there. I am genuinely unsure if you're being truthful or not, because at this point I'm kind of mixed, because it's like I just genuinely don't know. How heavy is this? I don't have an actual number for you. It is not light though. Okay. The fun thing about the CPU internal cells is that they're actually debugger's idea of what the cells should be when you go back to the actual running program. Those 16 words of RAM on the async card. So the fact that you can write into those means the bus write signals must be good too. Yeah, so the other thing about that, and I was talking about this with Usagi, is that we can read the console ROM. So that means that we can access data on the bus, and the console ROM shows up when we get into the memory monitor. We can go to those ranges of addresses and actually read that data. So something is happening that's correct there. But yeah, who knows, man? It's so frustrating. Reading's fine because it's running from that wrong. Yes. Yeah, but it stays fine. We can continue to read it. Like, I don't know what would happen if I tried to pull the ROM while it was on, but I suspect we wouldn't be able to read it from it anymore, because it's not like it's loading that into RAM. So this is the card cage with back there for the cards for the microNOVA. Now, as I mentioned, this is the minimum possible viable configuration. I have about 5 more cards that I could put in here that I've taken all of them out so that we can just work on this data. That is 4 more RAM cards and 1 more async card. But it's possibly the CPU card here that is causing us issues. So we're going to remove this, and we're going to take a much closer look at this today. All right. Do I have one of those inline pin connectors? I don't really know what you mean, but you might mean this thing. I don't know. Spec writing RAM is actually working. You just can't read it back because the async card is blocking it. If I can't read that back, then why can I read the... Are you saying there's a jumper on the async card, or what? I'm saying there's a fault on the async card. Okay. We're going to start here, and then we'll look at the other one. That was key switch with the deoxide. I don't think the issue is the key switch. The key switch looks like garbage, but I don't think it's the issue. Somehow. Ugh. There are high-res pics of the backs of the cards as well as the front. Someone could look into REing the schematic. I just took those today. I will have them up on the wiki this afternoon. So yeah, I only had front pictures previously. I retook the front pictures as well so that they could be shot at the same angle so that you can work with all that information normally. So you have two async cards. Try the other thing. Anything changes? We can't. So this is the other async card. On this card, nothing here is populated, and this whole area is either the disk controller or the console debug ROM. We don't know. This stuff's so poorly documented. Also, again, I'd like to point out, I have no idea what this wet stuff is right there. It's driving me nuts. Wait a minute, does it look like it's on here too? Wait a minute. And here. What's going on in the back plane? The backplane is 100% completely passive. It can't have anything leaking on it. But not all of those cards have caps back there. Okay, all of those cards have caps back there. Dude, I got no idea, man. I don't even know, man. I give up. Computer's cursed. No, so here's the thing. You can go look at the photos on the wiki. None of them look like that in those photos. This happened recently. The ESD strap's gonna tourniquet me. Didn't you clean them yesterday? I cleaned one. I don't think we deoxidated the backplane. No. All right. I'm going to cheat a little now. Because I'm going to act like I know things. Missing components on the other same card, all RAM, ROM, address, logic, RAM driving chips, only debug. It looks like only the debug console and nothing else. So you're saying that one has the debug console, but the address is probably different? Wait a minute, are you saying that one chip way up at the top, that the one ceramic gold chip could be the ROM for the debug console, maybe? 36 if you feel like looking it up in that weird data sheet thing. Come on, boot. One card with debug and one without. Okay, yeah, that's what I thought. That was my impression there. Can we test the caps on the boards? When do they got power? It started to leak. Maybe at some point. I don't really feel like it right now. I don't know. They're all over there doing whatever. I'm not that worried about it at the moment. Also, for the record, nothing floppy-like on it is what I'm saying. Okay, then how were the floppy drives and the hard drive being used? It could all be software for all I know. I don't know, man. Anyway, you can do exclamation point DG. Now, to bring up this page, this is the wiki page that has all of my current information on this stuff. I wanted this, not Nextcloud, get out of here. I wanted, hold on, it's making me sign in. Yada, because I refuse to run KDE Wallet because it's stupid. There we go. I wanted this thing so I knew what all the jumpers are. I spent last night working on this. So this is a description of all of the jumpers on the CPU card. So I'll be overlaying this in the video as I work on this, maybe. For right now, I'm going to have it off to the side so I can act like I know things. And then I'll be able to just say words. Getting the stand up here. There we go. Better. On Firefox. Full screen. Yeah, there we go. Full screen the image. Oh, that's perfect. So glad I made that 16 by 10 or 16 by 9. Okay. Diagram of the jumpers and your Saturday after working on it. Yeah, it's a bit like GPIB. So software, you're saying. Okay. Anyway. Recording start. Oh, the button's so far away now. Okay, so let's try that again. So here is the CPU card, and this may be the solution to the problems. I don't know, but we're going to try and figure this out today. But before we do that, I figured I would go over what all is on the CPU card for the microNOVA. Now, I have an image here that I'll put on screen that is a diagram of what a lot of the jumpers are on here, but I figured I'd walk you through this on the real machine here. So first off is W7. This disables the battery system that's on the machine. I don't know why this has both the battery and the jumper to disable the battery, but I'm kind of glad about that because it should mean, in theory, that even though I've removed the power fail option, the machine should still boot, but that's one of those things that could be throwing us off. I'll go up. Now, down here are a bunch of jumpers that are used to set jumper word register. This allows you to program in a set, this allows you to program in an address that can then be used as a starting point to run code. Now, that wouldn't be that useful in most situations, but there was a ROM card available for the Data General, and you could probably use this to specify a starting point within the ROM to start your machine from. So let's say you had a disk drive and you didn't want to have to type in the starting code. You could have the starting code in ROM on the PROM card, had the starting address for the ROM card in this, and bam, the machine would auto boot from a hard drive or something like that. Now, I don't know that there isn't a ROM on here for that, because one of the other things about this is that, well, this is marked as a 601, this is a 506, this is a 610. Data General used custom chips all over. Now, some of these may just be rebadged other chips from different manufacturers, because there are some other manufacturer chips on here, like this is a Texas Instruments chip right there. That's not a Data General chip, but I don't know what it is offhand. It's got a big S on it. So there are some other brand chips on here, but they use a lot of their own stuff. One of their chips that I do know here is this. This is a 606. This is a RAM chip. Some of the other RAM cards I have very similar chips. This is a 607. But this gives us onboard memory for just the CPU card. Speaking of CPU, that would, of course, be this. Now, this is probably a merged chip from the AMD, I think, bit slice chip that this is based off of. This is part of what makes this the micro of the Novas. The Nova line are mini computers, but this is the micro version. Matter of fact, they actually sold a true microcomputer version of this computer that was in a very similar chassis to the TRS-80 Model 4. Now, there are some other jumpers on here. We've got W4 over here, which is unpopulated, which would have enabled this. We're not using that, although we do have jumpers that are setting data in the jumper word register for some reason. I don't know why. Then we have W8 down here, also unpopulated, which would disable any local ROM, which would be for auto program loading. Then we have W5 down here, which is also disabled. Yep, right there. That would have used the jumper word register. Hold on. If inserted memory shall contain the contents of jumper word register with the device address of the APL option. Oh, so W5 would actually use this as the address for the APL. Apparently, W8 would just enable an address range for ROM. It's really confusing and not very well documented. We basically preliminary, like you're just learning how the computer works at all documentations for these things. We don't have like proper technical manuals and schematics and things like that. Anyway, moving on, we have W1 through 3 here, which configure the address. Moving on, we have W1 through 3 over here that configures the address range for this memory. Having all jumpers removed should put this at the lowest possible point. So that would let us be able to write to 00 through, I don't actually know how much RAM it is, or because it's octal. So the addresses are weird, but it'd be 2 or 4K. And that's pretty much it for the jumpers. I'll mention here, this is the connector that goes to the front panel, which has the PL start continue switch, as well as that rotating key lock. But there are also just loose holes through here that you could solder switches and LEDs to have everything on the card itself. And if you bought just this card from Data General, they would pre-install those so you could operate just this card by itself as a whole microNOVA system, because it's got a CPU, it's got RAM, it's got I/O. This is basically a whole microcomputer right here. It's kind of cool. But it may not be working correctly. So now it's time to turn our attention to looking at the backside, because I did notice some solder points. All right, there we go. Really unhelpfully organized, had to work out how we'd probe the bus. Like 3 different manuals, yeah. Sorry if I missed any messages there. I was just kind of rolling through that. Audio was jumping around with the video. I'm sorry. Tablet would be quite useful as portable reference like that. Took 2 iPad LCDs. So I had to rotate whatever response could be. That's interesting. Yeah, that's cool. Signetics, that would be crazy. All right. Okay. They even offered blinking lights, top notch. They did not offer blinking lights. There's a big difference between what this has and blinking lights. Blinking lights shows address and data encoded in binary through LEDs. This does not do that. Neither does my 4X, actually. So these are the ring ones. All right, let's swap to the macro. We have pretty much determined that if there are problems with the stream, there's nothing I can do about it. So I'm just gonna keep on rolling. All right, that is super duper dark. Let's bump the ISO. Oh, we're already at 3200. Dang, okay. Poot, I can't easily click that right now, but you might just be talking about one of these. So maybe I have the thing you're talking about. This clips onto a chip. I don't know. Again, it doesn't matter because we can't access this when it's in the computer. Okay. Would you look at all that macro? Oh, yeah. All right. Not pull the metal shell apart. There's the async card is above the CPU card. So no. All right. I really, really, really don't like these gold fingers with the oxidization along the edge here. That makes me real nervous, but they tested fine when I was checking them. Pretty sure this is the card I cleaned the back plane on. So, yeah, not that causing issues. All right. believe the first bad one I saw was in this area. So that one's not particularly great. That's not even one of the worst ones. Yeah, I don't know why so many pins are folded down. That's kind of concerning as well. Let's see if I can find a black thing to maybe put down to stop having as much light bounce off and into the camera. I know somewhere around here I have a piece of PET. No, it's oh, I forget what it's called. Plastic. That would work. That's a Fresnel lens. I mean, that it's dark, it would work, but it's not what I want. Oh, paper! I have black sheets of paper. Just use those. That's perfect. So watch this. Now it's bright. Now it's not. That's all it takes. If you're looking to clean PCBs without an ultrasonic cleaner, that flubber goo that I sell at gas station cleaner, if your dashboard works pretty well, that's wild. But I do have an ultrasonic cleaner. But I'm not going to clean this with that. I don't trust it. Magic of Hollywood, yeah. But no, seriously, like, here's the difference. Look at the blue spot, like right, wow, that, my finger's really huge in this when, you know, things. Let me get the plastic. Where did I chuck it? I see the pokerator. I'll just use that. So, oh, this is the weird pokerator that I gave Usagi. I don't want that one. Ugh, gross. It's the straight one. We want the curved one. Down there for signs of unhappiness. Okay. Camera mount doing the Jim Carrey. What is love? Oh, yeah, well, it's going to do that. We are super tight zoom macro, and it's just going to do that. All right, so in this area around the bottom, you can see that it's really bright and low contrast. All I'm going to do is I'm going to take a black sheet of paper, and I'm going to bump the camera with the paper. I'm going to put it under the light so that it covers the ESD mat. And there we go. We have solved the reflections. That's all it takes. Okay. Okay, let's find some bad solder joints. So that one's not great, but it's not like super bad. Where is that for reference? Okay, so that's right there. Okay, oh, it really doesn't feel good. You know, actually from here it looks even worse. Yeah, not thrilled about that. I think we're getting reflections off of the PCB itself as well. So that's cool. Okay, there were some worse ones. I don't like that one. That one is not like horrible. If I get the light closer, I can actually increase the aperture range, and this will look better. There we go. Just disable ray tracing, get rid of the reflections. There we go. the height of the board is inconsistent, which moves the point at which the camera focuses on it. Makes this more difficult to do. That one's a little suspicious. Wasn't one of the RAM cards I was looking at. None of these are as bad as I thought they were. Dude, holy moly. Okay, you know what? We're going to change tactics. We're going to go more straight down. There we go. Yeah, so that one looks super terrible from that angle. These pictures look great. It may also be partly my fault because my stream quality is not amazing. So, yeah, not super thrilled with that one. Seeing the ridge there, but that's not immediately like that one's bad. Same here with that one. Not my favorite thing to see. What are we searching for? Cracked solder joints. So I will hopefully find a smoking gun one here. But it's hard to say. Dude, the focus range is just... This thing is tall towards one side, and it just doesn't stay in focus. That's maybe not a great one right there. Not as bad as the Tandies, at least. Yeah. But I swear I saw one really bad one. I don't remember where it was, though. That's bad right there. So you can see a crack underneath right there. That is 100% example of a bad solder joint. That's right next to the card edge connector too. Oh no, that's on the front. Oh, interesting. Well, if that's the front, then the bad one I saw might be up here. So I thought I saw it on the front. Not super thrilled about that one. This wasn't as bad as I was hoping it would be. I was really hoping for some smoking guns. Ooh, though. That is very clearly retouched. So that could be a sign that problems were found and fixed. Not going to say the same about that one because it's on the ground plane, so it's a bit of a different story. Could be there. I mean, there's not a huge amount of space between there. Could be something like that. Like those ones are all pretty sketchy. That might be one right there. That doesn't seem... Yeah, there was a bodge wire. There's a lot of bodge wires on all the data general stuff. They like to design things 5 times. So yeah, there's your bodge wires. The bodge wires are more likely to be okay. Where bodge wire was, but isn't anymore. I mean, this right there, because they probably just nicked it with the iron when they're putting that on. I mean, they did it on at least one. It doesn't seem like they did it on all of them, Majenko. Oh, there we go. That's what I saw. Boom. That's definitely bad. So, in the middle. Yeah, this is what I was looking for. Yeah, that one's awful. Well, so I was looking for particular examples so that I could have something to show in the video as to why I'm doing this, because I don't like the idea of indiscriminately trying to repair something, you know, just hoping that it solves it. But seeing something like that there, that gives evidence of why this is a valid method to try and resolve the issue. So we're going to talk about this for a little bit. Just joined on cracked solder joint. Yeah, I'm pretty sure there. Yep. This is on the CPU card. I'm going to talk about it a little bit here. So, all right, hold on. So this took me a little bit to refine here at this zoom level, but this is, they made me realize I really needed to look at this. So we have a gold leg right here. So that should be tinned to match the rest of the solder, and it's not. And then we can see down here at the base, there is a crack. And the fact that this is cracked and that the solder on this pin didn't flow up and cover the entire pin like it did the other ones on the same part tells me that this solder was not heated up enough. So you could consider this a cold solder joint, and that's one of the reasons why something like this will fail. So all of these pins here that are gold still were not properly heated up, and the solder is much more likely to have issues. Look at this one. So we can see that there's a blob of solder on top of the pad there, and then the tip of the pin is just really crusty looking. So yeah, there's another one right there. This is a really bad solder job on this particular part. And there are other things on here that look like this. I'm pushing a piece of paper out of the way that I'm using to cut down reflections. So things like this are what I'm looking for on the CPU card here to try and diagnose potential issues with it. So there were a couple of other things I found, and there are some other ways that you can look at this to see issues. So there's a ring at the base of this pin right here that you can see. That can be internally cracked solder sometimes, and that can be an issue. So that's not great either. You want a solder pad to kind of look like this. So it looks like the solder flows up smoothly and you have a nice rounded base between the pin and the solder. When you have something that looks like this, it's a really bad sign. Now, like I mentioned, there were a couple of other things on here that look like this. I believe I found one over here. This one's a little bit more difficult to see, but there is a slight crack. I can feel it with this right at the edge right there. That's not great. And yeah, so that's a little harsh right there. That one, a little harsh. Ooh, can see some minor cracking there. So what I think I'm going to do is I'm going to spend a bit of time here, and I'm going to go through, I don't know if I'm going to say all of the pins, but a significant number of pins on this CPU card, trying to make sure I can't find anything. I don't know how they got holes in the solder like this. Oh, probing it, probably. That's, man, they went to town on those suckers. Jeez. So yeah, I want to make sure that there is nothing that looks bad. That, you can see some waviness and a crack right there. So yeah, I want to go through these and just look over, reflow, touch up some of these to make sure that everything looks good, because this is definitely the kind of problem that could cause the inconsistent issues that we're seeing. All right. Sometimes those holes form from air bubbles that pop to the surface. Well, these ones I can, now that I'm looking at them up close, they were definitely stabs from meter or probes. Yeah, pretty sure that's what those are. Yeah, actually, yesterday I accidentally stabbed myself in the stomach with one of my super sharp probes I'm using on the Fluke right now. So, surprised it ever worked properly to begin with? Yeah, really. Say it didn't look like it hot enough. Whole board barely got it done.
Tier 1 and says, end of line.
Mighty Halo, thank you for the tier 1 sub there, and for 14 months. That's that many months. Thank you so much. But yeah, so I think we've got some work to do here, and that this could realistically be the issue. I think it would make sense. All right, so yeah, that's how I was doing all that. So you guys are getting this view. Weirdly shoddy for how much this would have cost. And now we just solder on the board for 84 years. All right. I am going to need the light for trying to see edges. I'm just going to real quick for giggles. I want to look at the async card to see how bad it is. Is this machine towards the end of production? I don't actually know. If I was to guess, I think this is a used machine that the place that I got it from bought it as. So it was not new to them because they got an 82 and it seems like all the parts are like 79 on them. I mean, there's an 80 on this. So it is possible that it was midlife or end of life. I don't know. These all look, they may not be perfect, but they definitely look better on average than that does. The legs are trimmed much better too. Yeah, overall this is way, way better. All right. Also, I just did a thing I've been wondering about if I can do, and it looks like the answer is yes. I removed the card while the serial connector was still plugged in, and I think I'm going to be able to reinstall it while the serial connector is still in. Yeah, that is weird that you can do that. It totally works. Okay. Okay. Wasn't sure how old this was. Does it have electrolytics? Some minor ones that are not critical. The major ones we've already reformed. Already mentioned 82. Would think at 79, 77, 79 it would have been better. I don't know. Again, this may have been used machine or new old stock. I don't know. So, okay, let me make sure my soldering iron is fully free here. Kind of got tangled up on the desoldering gun. Whoop! Let's not do that. Oh man, this is gonna be rough. I know I have a thing or two for this. It's a real shame. I really need to modify that. I have a USB microscope that I could use for this, but it has a stand integrated into it. So if I tried to use it for this, I would just bump it up against the side, then it wouldn't work. I have a giant magnifier though. I would like to know where it is because I'm not going to be able to. You know what? Maybe we do this. Maybe we do this as macro. Which will be way more fun to watch. Give me a zoomed in view, but it's not going to be perfect. Okay, we might go for that. So if we look at the messed up area, where is it? Here? There we go. That area sucks, man. Okay, new PC wallpaper. Well, what I'm talking about, I literally have Celestron USB microscope. I just or UVC. The only problem is that it's a microscope, so it's got a base and then an arm. So I can't just arbitrarily stick something under it. And the cables connect to the bottom, the display's at the top, so there's stuff running through the base. So, any idea which chips are near the bad solder joint? Hold on. That's that guy. Right there. There you go. Look at him. He's all stupid, badly, poorly soldered. Look at that. It's not even coming up on the legs. Like, that's pretty bad. Yeah, I'm curious what it is. Watch. It's differential buffer driver, or differential bus driver is the name of the chip. Wow. That's so bad right there. That's such a cold solder joint. Memory transceiver, yeah. Wait. It's literally memory transceiver? Wait a minute. You telling me? Wait. Wouldn't that, like, make way too much sense? Like, hold on. Wait a minute. You're saying we're gonna solder this back and it's gonna work great? Hold on. All right, so one of my viewers asked me, what chip is it that those pins are on? And we flipped it over, this 634. Now, there is a data sheet from Data General that kind of tells you what the parts are. And this is apparently a memory trick. I don't know if that would be important to, you know, working with memory like we're having issues with, but it might be worth a shot trying to fix just this chip and then chuck it back in and see what happens. So I think we're going to do that and see how this goes, because that would be interesting. Which pins are bad? I don't know. They're all so awful. I mean, look at them. They didn't get any of them cold enough or hot enough. So I really can't tell you. So here's what we're going to do. We're just going to resolder every single pin on that chip. Every one of them. Did a terrible job trimming the leads. Yeah. Man, it is really rough. All right. All right. It's my on there. Is there no sound? I mean, I wasn't talking. That's a Met cow with a through-hole tip. No, that's just a normal Met cow. He works rather slow. Difficult to work quickly when you're trying to make sure that you guys can see it all on camera. So for giggles, flip it over. You know, that has not changed considerably on that side. Huh. Maybe I didn't dwell long enough. I mean, those look pretty good on that side. Although there's one that managed not to get fully covered. Is that a reflection or is that... Yeah. That has so been hand soldered. Yeah. Yeah. Definitely it's a replacement part at some point in the past. Oh, yeah. Could also be the gold pin, solder wets to gold less quickly than it does tin. Yeah. I'm going to just real quick like clean that. Oh, cool. The air compressor makes it shake. Okay. That was by far the worst looking chip on the board. So, I give it a shot. Just visually confirming I don't have any shorts under different lighting. One of the pads was damaged by to the point at which I'm going to confirm it's still making good contact. Okay. Stabby probe time? Kind of was. Those are my sharp ones. I didn't try to push the tip through the board to the other side, though. Diodes next to the chip good? I don't know. All right. So I think what you guys were talking about there in the background is that this chip, the things that we would wish it would do in circuit, maybe. So this probably isn't going to fix it, but we're going to do it anyway. We're test it because wouldn't that be sweet? And this one was definitely bad. I'd be lucky first time for anything, yeah. All right, now that, hold on, sticking. All right, now that that chip is reflowed, let's see what happens. Maybe that solves it, maybe it doesn't, and I got more reflowing to do, but that one was bad and seemed contextually relevant to the exact issues we're having, so let's find out. Waits 5 years, fault is cold solder joint. I mean, it wasn't known to be bad. I think it was assumed to be functional. Managed to catch part of the live stream, Zoggy? Awesome. It was a lot of fun. You can also watch the VOD on YouTube. All right, it looks like minor issue and we're back. So we're all good. I think my server just dropped 1,500 frames. So it was probably server to Twitch. Home encoder went sad, okay. Somehow I lost the male-to-male pin joiner thing. Cool. We need that to be able to plug the terminal in. How did that disappear? Oh, I found what I was looking for the other day. Actually, it might have even been before stream started. It's BNC to RCA adapters. How did I lose the joiner? I have no idea where it is. This is annoying. Was there a terminator thing? The terminator is on the back plane right now. What I'm missing is, in order to connect the terminal, you'll see this is a female single row IDC connector. That's the same thing that comes out of the back of the terminal or the computer as well. You need a male-to-male joiner to plug them in. It fell off. Here it is. So I don't know, somehow in the front, but yeah, it requires this thing to plug the two things in. It's really dumb. It comes with this little plastic thing that it goes in the middle of to hold them in place. It's just, ugh. I haven't been using the plastic thing because we've been swapping it back and forth so much, but I guess this time let's just go ahead and do it. All right. Don't worry, I'm not doing anything yet, just getting it prepped. It's almost janky enough to be designed by me. It's still the most gorgeous computer peripheral ever made. Okay. this, and this, and this, this. Okay. And then back to here, and then boop, you got the wrong thing. Boop, you got the right thing. All right. All right, CPU cards back in, machines all plugged in, terminals on, ready to go. Let's find out what happens. It's first time soldering on the CPU card in Nova. Did not think I was gonna have to do that. Went straight to the memory monitor. All right. What are we at? We are at 704. Okay. Let's look at 2 now. Can we deposit? Moment of truth.
Says there, unauthorized third-party solder detected. Contact data general field service for assistance.
Okay.
CHER 100. End of line.
So, I'd still like to point out, though, it just works every single time I turn it on from scratch. So, a thermal-related problem really makes sense. And thermal-related problems can definitely be bad solder joints. So, we still may be down the right path here. But where is another problem. So, I'm going to have to keep going. Can't do that address, Spongy. It will always wrap that first one because it's only 5 octal bytes or whatever. Or the rest of the circuit is not rearming after power down. I don't know. Recheck and check if it restarts again. I mean, here's full off. Full on, or reset, on, start, and fail to start. Two of the gold chip pins, are those the same? No, one of them was different looking, I think. And G Paradise, no. We do know where a ROM is, but we know that this should be memory. Okay, we're back in. Addition, 1 all 7s, not that. K for cancel. 1, 1, 2, 3, 4, 5, is going to be the ROM for the console debug. So, yeah. Well, the ROM, 77-400, we've always been able to read the ROM. That's never been a problem. Try data. 1, sure. 2, 1, 2, 3, 4, 5, 6. 2. I mean, we can do 1, 1, 2, 3, 4, 5. No. We call 1-800-DG helps. Yeah. Gonna get Dell, and then they're just gonna tell me no. We can always read but never write, so the read-write line is stuck. Maybe. We thought we saw the memory lock or whatever line, and it looked like it was changing. You missed nothing, Poot. You missed nothing. Well, we can write to the potentially weird. Here's what Ben is talking about, okay? I'll do this on stream again here. So if we do 0A, all right, no, 0 capital A, this is an accumulator, all right? Actually, I want to reread something from the manual, because it said something different about this accumulator that I hadn't previously noticed. It said something about it's, I think, accumulator 4. So 1, 2, 3. would store some, the value of, I think accumulator address 03 down here should have the address for the point at which execution was stopped for the console. So, but we were never running code. Yeah, anyway, let me show this. So let's look at accumulator 1 again, 0A, all right. We can do plus 10, all right? And then it's gonna wrap, oh, okay, let's not do plus 10. That's gonna, 7 is the maximum value, so it ends up being weird. So if we do 0A again here, now it's 405. We can do math. We could also set this to 2 plus 3. Boom, reread it back, and now it's set to 5. We can do math that way, and we can store it in these register things. It's really strange. So it's difficult to explain. I think this is a programmer manual. Can you now do 7560? Yeah, 7560. Boom, all zeros. I think because W7 is out. Oh, 7756. 77560. Boom. What? Hold on. 0. Okay. 77560. We literally can't put dead beef. It doesn't. Also, it's not basic. It's basically assembly. That was a really bad way of phrasing that. Deposit into that cell. I mean, we can't, though. No, I'm saying the way the syntax works, we can't. It's not possible. If I type 77560, in order to open the cell, okay, to be able to write to it, we press the slash. But then we see that it goes to the internal CPU register or cell instead. It's impossible to write a value to 77560. It is a Dasher D2. And technically it has the enhanced keyboard, which means it has these 3 keys. I've found out recently. This is such a weird problem, man. No, we have not fixed the startup issue. You know, I'm going to do a stupid check. G Paradise, that's in this machine. There's a back plane right here in this, and those cards are in there for the memory that you're thinking of. Dude, thermal camera software, what on earth? It loaded completely wrong. There we go. Well, that's mildly interesting. RAM's all cold. I've been saying it's not possible to probe the card. It's not explicitly true. It's really hard to probe the card, but it's not actually impossible. Goodbye, safety things. Ha ha ha. You're so stupid. No one likes you. Okay. You might be about to see me look at the chip manual, although we only have 7 minutes, which annoying that we found something so indicative of something 7 minutes before the stream ends. I'm gonna break off that pin. What's VBB? -5, okay. Well, Matrox, again, this was supposed to be functional when it was last used. Wow, getting in here without shorting to anything else, real hard. Okay, this is some kind of rail. VSS is 20. Are they 10 or 20 pin chips? Okay, so this is 20. So this is ground to VSS. -5. Can you give me the pin numbers again? But does it not have ground? Oh, that's weird. They don't have ground? G and D on 20. Okay. I want you to see this. I am on this cap right here. Oh, you know what? I don't know what that rail is. That might be +5. I need to find a good ground. There's probably one up front. Hold on. Let me plug this in. This should be ground. Okay, so here to there. Okay. To that's not ground. So that's pin 20. Ground. It's not ground. I'm mildly concerned about what I may have done over here. I don't know what happened over there. I'm not thrilled. I want to see it boot right now, really quick. Just give me a warm fuzzy. One moment. No probes. One moment. Okay, good. All nice and happy. Okay, good. Whew. I know you're saying pin 20 is ground, but I'm saying I cannot corroborate that. The chassis is definitely grounded. Shame I can't get to that. So I can do that. Okay. We're going to use that for ground. But oh, that one is grounded. Weird. Okay. So confirmed ground. Okay. All right. Pin 1. Pin 20's RAM chip. Pin 11 should be around 15 relative to the pin. Pin 1 is minus 5 volts. Okay. Let me try and do pin 1. It really doesn't look like a rail. Trying to find a pin 1 that doesn't trace going between it and pin 2, because the clip is really chunky. doesn't go on well. And now it's not even closing. Okay, so that's 415 ohms. You know, I'm just going to do this. What are their volts? We'll see what happens. Okay, well, that's a bad ground reference. Good job, me. Screw it. Minus 4.3. Seems a little low, but probably okay. Okay, pin 11 should be around plus 15. Oh, there's a really good pin 11 candidate, but I got the stupid clip stuck. There. This. The cap here, oh my gosh. The red clip has like died. The spring, it's grinding. It's not really working well. There. Okay, we're going to go directly on this cap. That should be 15 volts. There we go. And we're getting power. So why are the... Look for a clock signal. Rip Goldfingers, man. I don't know if I can. Well. No, it was 4.5 volts, but there was no signal. Or there was no pulse. It was just solid. Why is it not working? Oh, there we go. Okay, so ignore this. Overlay. Oh, yeah, I guess that kind of was over the multimeter. All right. Channel 2. Hide channel 2. How do I toggle? I don't remember how to hide channel 2. This is just going to make it run slower. Oh, waveform off. Boop. Channel 1. Okay, here we go. Oh, well, maybe it's just too fast for the stupid fluke. Fluke kind of sucks. Take 30-minute break, throw out movie. Change what's the cliff notes. So cliff notes are we reflowed a memory transceiver chip on the CPU card, and it didn't change anything. And then I looked at the whole thing with the thermal camera, and I saw the RAM is cold on the CPU card. So we're wondering what on earth's going on with the RAM that it's not doing anything. Or maybe it just runs cold. We don't actually know. But that doesn't seem right. But we went to CCS. $15, man, you're asking for a lot. What's the temperature range between hot and cold on the thermal camera? It's going to be pretty cold because it's got the aluminum in it. Low was 22, and it was actually one of the RAM chips. High was 48 on that image. And was, I think, this weird resistor doohickey thing. $15. All right. 11, 12, 13, 14. 11, 12, 13, 14, 15. I don't think I can do that. No, I cannot easily do that. Aw, stupid old brittle plastic. RAM chips missing. VAC heater voltage, yeah. Yeah, they're all, I mean, I guess if they're... I mean, this is connecting two chips to each other, but it's not really a problem. I just have to find a way to do that because there's like stupid little things on the way everywhere. Capacitors and such. Yeah, I don't think there's a single clean one that I can grab onto because this is too big and then there's parts in the way. Yeah, I think we have to give up. So the RAM chips on the card get warm. Yeah, I was wondering about that. I was thinking we should put the one of the mem cards back in. I don't remember. Do I have one that has 606s? Let's just do that. That'll be our last test. I cannot easily measure pin 15. Sorry. Gotta love weird RAM chips. Good idea. See if all RAM's called. Yeah. So that one's 607. This one is 606. So here is same. Okay. So, okay, I didn't think I pushed that in all the way. I'm putting this in next up. Slot. Double check. Yep, that one's there. We get the camera going. So many notifications. Okay. We can't easily see the async card? I don't know. Okay, here we go. So yeah, stuff's getting warm on the CPU card and the async card. Not the RAM. So async, I don't know where the RAM is on the async. But RAM there, I mean, maybe a little bit. So the cores or the centers are getting warm. It just runs cool. Or are those tantalums? No, that's the RAM. That's a chip. I think those are the centers. But they run way cooler, or... Okay, that's into the console. All right, well, that's something. We have to stop now. I am over time already. But that's a new fail. Please stop. You need to stream. All right. It's something. I don't like that, like a lot. I don't like that. Reflow oven time? Yeah, I don't know. Let me look at something really quick. Chip select's not on the back plane, right? There's like one horizontal page in this PDF, and it's making the whole thing all wobbly to try and read. Oh my gosh, I just went back to the top. Black plane uses multiplex, something nonsense. Okay, well, we're done. We're done. All right, that's annoying. Chip clip. Instruct part CPU onboard RAM is being accessed either, so we need to find the common thread between the two. Yeah. It could still be a bad solder joint on the CPU card. I think I'm gonna have to spend a bunch of time looking at that, probably off stream. I don't know. We'll see. I don't know what my current plans are because I got a bunch of stuff I need to do. So, Majenko, maybe, yeah. 100% my hunch is fill lines, whole purpose is disable our RAM system, async ROM, yeah. The old chip function over CPU boards, you know which functions, most chips, yeah, so we'll see how it goes. Don't resolder every pin. It's a good way to destroy pads. Weak glue. Copper and fiberglass. I already saw whoever reworked the last one made a mistake. I am less concerned about me doing that. I'm gonna say that I have enough solder seat time that I feel confident that I'm not gonna have an issue with that. But I don't like shotgunning solutions. I want to know. Ask you how you know, all right. But I don't want to shotgun a solution. That's the thing. Lifted pads by just applying a heat. All right. Well, okay. I am not 100% sure where we're going to go from here. I have a handful of ideas that I'm going to think through and a lot of work to do with some of the materials that I generated today. But yeah, that was an interesting symptom there. Yeah, riser card, flying leads, yeah. Because we just went from I need to probe the back plane to I need to probe the cards, and that's a lot harder. So yeah, that's fun. The card edge sockets are most likely, I'll take a picture of that now, but they're probably 200 mil pitch. That's the common thing. Everything is available with enough disposable income, yeah. I mean, when you're doing it as your job, it's not actually disposable income. I mean, if they're like $100 a connector, you best believe I'm writing those off on my taxes as expenses. There's no sane person would do that for a hobby. Oh, that's right. This one sucks to remove. Hold on. Let me push on it from the rear. Come on. Ah. Just for more samples. Yeah, let me just confirm that they're 200 mil pitched. They're not that expensive. No, I didn't think they'd be that expensive. But that's millimeters. No one wants millimeters. Oh, they're 100 mil pitch. Okay. So 100 mil pitch card edge connectors. That's not that bad. Really, though? Okay. So think you're ahead of me. Got some really hack of the CPU card. I do, yeah. They are. So yeah, if you want to see them, actually, hold on. I can show you those. So is it this? Yeah, it's that. Okay. Also, let me just hide that. Here, boop. So CPU is kind of in the middle here. So that is backlit CPU there, but I also have just standard illumination. No, that's async. Hold on. CPU's around here somewhere. I got them all. I'm going to bring them home. I didn't put it in there, but I do have the really nice card. Oh, there's CPU. So I have the really nice card photos I set up and took today. So we'll be able to look through that. I have front, I have back, and then I have lit front and back. If I open the JPEG, it'll like it a lot more. There we go, just as an example. So we'll have good options for looking at everything there. Yeah, all right. Those photos are not on the wiki yet because I took them literally like 10 minutes before I started the stream. I did not have enough time to get them processed and uploaded and all that fun stuff. Buy a poster of that backlit photograph. I don't think I can sell that because that is quite literally artwork. But yeah, front and back, we can start tracing out memory portions by looking at maybe figure out good price. We don't have schematics, but we do have data sheets with memory chips. Yeah. We don't currently have schematics. So, all right. Might know what I'm doing this week. Okay. So, let's connect to the server and run the outro here. So, we're going to work on data generals so you guys are sick of them. Because, yep, they're not going to make life easy. So, we'll see how this goes. Something's got to give for diagnostics here. I don't know if it's going to be a board extender or probe pods. I mean, I might need more of those. Not because I need to measure so many signals, but I'm gonna leave them on there when I do stuff, so yeah, I don't know. Mullins gets his bad way executing code. Yeah, I think it's gonna be this for a little while, which kind of is a problem. So we'll see how this goes. But all right, this was an interesting day. We got the floppy drive done, so there's that. It's probably good to go. We think we know what the device code is. I don't think you were here for that, Usagi. We found the jumpers for the device code, and it did encode out to octal 33, which is the default. So we believe the floppy drives are the default device code, so we should be able to do 33L, but I think we also need the bootloader to be able to load disk from the... but yeah, so maybe, I don't know. So, yeah. Anyway, if you enjoyed this stream and you want to see more giant blue heavy computers, then you probably want to follow to be notified when I go live again next. If you want to help support the channel, you can find me on Patreon or get a shirt like this one. But that's going to be it for now. There is a lot of work ahead of here. And I will see you next time.